Welcome to episode 32 of the series on water chillers, prepared by Mundo Chiller, the channel for frozen water plants. Let's start by saying that centrifugal pumps are an essential part of an air conditioning plant with chillers. They are responsible for providing the flow and pressure to bring the chilled water to all the points required by the installation. Pumps used in HVAC chiller systems are mostly used for one. Centrifugal pumps are used to send water to the chiller cooler, to turn it into ice water. These types of pumps are called primary pumps. 2. Centrifugal pumps are used to send the chilled water that comes out of the chiller cooler to the air handling or fan coil units, or even for cooling machines and industrial applications. These types of pumps are known in the facility as secondary pumps. 3. Centrifugal pumps are used to send a stream of fresh water at room temperature from a cooling tower to the chiller condenser for cooling. This circuit is independent of the chilled water circuit. These pumps are known in some chilled water plants as a condensate pump. 4. As a percentage of the water that cools the condenser evaporates in the cooling tower, it is necessary to replace it with water from outside. For this, in many installations it is necessary to use well pumps. In some more modern chilled water plants, the primary and secondary pumps have been unified in a single pump room that is responsible for performing both functions. Mostly these types of facilities have inverter-type controllers to change the frequency of the pump motors and vary their speed. In the animation that we are showing on the screen, we can see water pumps in an ice water plant. Water pump, to feed the plant's chiller evaporator, and simultaneously the air handling unit. Water pump, to feed the plant's chiller condenser. Now we are going to explain the internal operation of the centrifugal type pump. 1. The pump receives the fluid through its center. 2. The pump wheel is called an impeller, and it is made to rotate by the rotation of the motor. Does this rotation produce centrifugal forces? 3. The centrifugal force is responsible for carrying the liquid fluid, from the center of the wheel, to the end of the wheel. 4. In order for the fluid to remain longer in the wheel and to be able to print higher speed, the impeller has a curved shape. 5. Now the fluid picks up speed. 6. Speed is a form of energy, called kinetic energy. 7. Since the objective of the pump is to generate pressure, the kinetic energy must be transformed into pressure. 8. To carry out the transformation of energy, it is required to pass the liquid fluid through a nozzle. 9. The nozzle is responsible for gradually slowing down, with an increase in the area of passage of the fluid. 10. This increase in area gradually converts kinetic energy into pressure. 11. The nozzle is located in the pump casing if it causes the snail shape that we see externally on the pump. 12. The fluid leaves the casing with high pressure. What else should you know about the pumps used in chillers? 1. The pump must never be started dry. 2. The pump has seals to prevent the escape of water through the shaft, and it can suffer damage if the pump is turned on without liquid. 3. The priming of a pump is the process that is carried out so that the suction pipe is filled with water. 4. Cavitation in a pump. It is a phenomenon by which water can start to boil at room temperature, which causes major damage to the pump. Cavitation can occur due to the lack of pressure in the suction of the pump, and it occurs when the tank where the water is, which is sucked, is far below the pump, or there are many accessories in the suction pipe of the pump. The pump, such as valves, elbows, filters, etc. 6. Never install a motor with a different speed from the original, even if the power is the same. 7. The electrical power depends on the flow of water and the pressure that is needed. 8. The correct alignment of the pump with the motor or shafts with pulleys avoids damage, for example, in bearings. Use clocks for accurate alignment. 9. The installation of pumps requires accessories such as valves and filters. 10. Place the minimum of accessories in the tube that enters the pump through the center or suction tube. 11. The curve of a pump allows us to know its behavior at different water flows. Another thing to know about centrifugal pumps is the phenomenon known as water hammer. Water hammer is a sudden increase in water pressure that occurs inside the pipe when closing a valve or faucet quickly. The water hits the closed valve and bounces back like a wave. This rebound continues until the water hits an impact point and the energy from the water wave is more evenly distributed in the piping system. These sudden increases in pressure can damage valves, taps and other equipment, even causing bursts in the pipes. It is known as water hammer, due to the sound that can be produced, similar to hitting the pipe, with a blunt object such as a hammer. The water hammer does not occur only if we open or close a shut-off valve abruptly, but it can also happen when the pump is started and stopped. A direct start or stop. Start a large column of water suddenly moving through the pipes, and can produce this effect. To avoid water hammer, it is possible to use soft starters, which perform a progressive start and stop, through starting and braking ramps. Thanks to the use of soft starters and three-phase pumps, it is possible to avoid the effect of water hammer in our system, thus avoiding problems in the elements of the hydraulic circuit.